And we have something called direct memory access, which we normally refer to as DMA. Let's say we're trying to read from a disk. So we want to read a block from a disk. Or actually, we want to read a bunch of blocks from a disk. Without DMA, here's how that would work. So our read is in the kernel. So let's say we've got a disk. And in the kernel, we have a read for the disk. And so we want to tell the hardware to read a block. So we would tell the hardware to read block B. And then we wait, which will basically tell us that that block has been read. Okay. Well, it reads it into its own memory, okay, into the device's memory, not into our main memory. So we now copy, and instead of calling it our memory, let's just call it main memory. And then the read is complete. So we tell the hardware to read block B. That's going to read it into its own hardware, right, its own memory. And then we will go ahead and copy from the device main memory. So what we'll probably do is copy using the device memory mapped I/O. So it's actually available in a particular region of memory that's memory mapped. Okay, but it's not in the main memory, it's just in the address space. And so when we read from there, it actually goes to the device to read. So the CPU will read from the device, write to main memory, read from the device, write to main memory. Okay. But wouldn't it be nice if the operating system, the kernel, didn't have to get involved in actually doing this copying? And so that's what direct memory access does. What direct memory access does, it says for certain devices, we're going to actually allow the device to have access to the main memory bus. So the distinction would be, this one is without DMA, and this one's going to be with DMA. So here, what would we do in the read? We would again tell hardware to read block B into some particular physical address. And we give it the physical address. So what happens then is we can still get notified when that completes. Okay. When I say wait for interrupt, there can actually sort of this part of the read can wait, but we can go ahead and doing other things. And so the kernel can still be executing instructions. It doesn't sit there in a tight loop. It can just sort of go about your other business, and then you'll be notified when this is finished. But when you're finished, the copy has already happened. So there's no need for it to go ahead and do this copy. This works with something called cycle stealing. So what happens basically is we've got the memory bus, and it's possible when the CPU goes to try and access the memory bus, a cycle of the memory, it may have to wait for some existing DMA to be happening. Okay, so there's no free lunch. If the CPU were trying to access memory at full speed, there'd have to be some slowdown for this DMA happening.